Good morning, everyone. This is Tanya from ECE third year. I'm going to explain about distance vector routing and link state routing. Distance vector routing is also known as Bellman-Ford algorithm. It is a dynamic routing algorithm. Has two things: best path and less number of hops. It works in two steps. First, each router prepares the routing table all router present in the network distance in its neighboring route. Step 2, each router exchanges its distance vector with its neighboring router only and prepares a new routing table. For n router, this step is repeated for n minus 2 times. Let us see an example. W, X, Y, Z are 4 routers are connected with each other. First, local routing table. It prepares a local routing table for each vector. For W, distance for W to W distance 0 and next hop W to X distance 2 next hop X, W to Y distance 3 next hop Y, W to Z distance 1 and Z. For X to W distance 2 next hop is W, X to X distance 0 next hop is X to Y distance 4 and next hop is Y, X to Z distance is infinitive and there is no next hop. For Y distance is Y to W distance is 3 and next hop is W, Y to X distance 4 and next hop is X, Y to Y distance is 0 and next hop is Y, Y to Z distance is 7 and next hop is Z, Z to W for Z to W distance is 1 and next hop is W, Z to X distance is infinitive and there is no next hop, Z to Y distance is 7 and next hop is Y, Z to Z distance is 0 and next hop is Z. And the step 2 is to exchange the distance vector with the neighboring vectors to find the best path. For W, it is connected with to 3 routers X, Y and Z. So we are taking the values from local routing table for X, Y and Z. Now we are going to find the possible ways and the best path. For W to X, there is 2 possible ways, W to X and W to Y, Y to X. Cost of these are 2 and 7. So best path is W to X, cost is 2. For Y, there are 3 possible ways, W to Y cost 3, W to X, X to Y cost 6, W to Z, Z to Y cost 7. The best path is W to Y cost 3. And for Z, W to Z cost 1 and W to Y, Y to Z cost 10. Best path is W to Z cost 1 and the new routing table for W is W to W 0 distance 0 and next hop is W, W to X distance is 2 and next hop is X, W to Y distance is 3 and next hop is Y, W to Z distance is 1 and next hop is Z. And for X, it is connected with W and Y. So we are taking values of W and Y. For from the X to W, there are 2 possible ways: X to W 2, X to Y and Y to W 7. The best path is X to W cost 2. For Y, X to Y and cost 4, X to W and W to Y cost 5. Best path is X to Y cost 4. And for and as of Z is X to W, W to Z, X to Y, Y to Z. Best path is X to W, W to Z cost is 3. And the new routing table for X is X to W distance 2, next hop is W, X to X distance is 0 and next hop is X, X to Y distance is 4 and next hop is Y, X to Z distance is 3 and next hop is W. For Y, it is connected to W, X and Z. So we are taking the values from local routing table W, X and Z. The possible ways from Y to W there are 3 possible ways. Y to W this cost 3, Y to X, X to W cost 6, Y to Z, Z to W cost 8. The best path is Y to W cost 3. And for X, Y to X cost 4, Y to W, W to X cost 5. Best path is W to X 4. And as of Z, Y to Z cost 7, Y to W, W to Z cost 4. The best path is Y to W, W to Z cost 4. And the new routing table for Y is Y to W distance 3, next hop is W, Y to X distance is 4 and next hop is x, y to y distance is 0 and next hope is y to z distance is 4 and next hope is w. And for z, it is connected to two routers w and y. The best possible ways for z to w, there are two possible ways. Z to w cost 1 and z to y to w cost 10. The best path is z to w cost 1, and for x, z to w to x 3 and z to y to x cost 11. Best path is z to w to x cost 3. For y, z to y cost 7 and z to w to y cost 4. Best path is z to w and y to w to y cost 4. And the new routing table for z is z to w 1, next hope is w. Z to x distance is 3 and next hope is x. Z to y distance is 4 and next hope is w. Z to z0 and next hope is z. Now link state routing vector, it is also known as Dijkstra algorithm. It is also a dynamic routing algorithm. States two important things: shortest path and based on the least cost. In link state routing routing, each router shares the knowledge of its neighbors with each other router in the network. Based on the global knowledge, that is, it has a knowledge about the entire network. The link state routing algorithm exchanges the information only when there is a change in connection. Information of each router needs to be transmitted all over the network. Phase of link state routing, there is two phases. First, reliable flooding. Router shares its information using flooding technique. It is classified, furthermore classified into two initial state and a final state. Initial state, it is each router gets to know the cost of connection of its neighbors, and final state, the information about the entire router network is known by each other. Second is route calculation. Every route uses a shortest path computation algorithm, Dijkstra algorithm, to the cheapest, that is most optimal router to every router. Example, there are 4 routers and it is connected with each other. First, how to write the link state tables for M, N, O, P. For M, it is connected to N, O, P and the distance are 7, 9 and 5, and N, it is connected with M and O, the distance of 7 and 1. And for O, it is connected with M, N and P, distance are 9, 1 and 3. And as of for P, it is connected with M and O, distance are 5 and 3. The link state is shared among all the routers in the network. This is updated on regular intervals with sequence numbers and TLT, that is time to live. Routing tables of others are maintained. The original routing table for M, the distance is M to M distance is 0 and next hope is M. M to N distance is 7 and next hope is N. M to O distance is 8 and next hope is O. M to P distance is 5 and next hope is P. And for N to N distance is 7 and next hope is M. N to N distance is 0 and next hope is N. N to O distance is 1 and next hope is O. N to P distance is 4 and next hope is O. And for O to N distance is 8 and next hope is N. O to N distance is 1 and next hope is N. O to O 0 and next hope is O. O to P distance is 3 and next hope is P. For P, P to M distance is 5 and next hope is M. P to N distance is 4 and next hope is O. P to O distance is 3 and next hope is O. And for P to P distance is 0 and next hope is P. That's all. This is how we calculate the original table. Thank you.